Welcome back, chat. Today, we are going to jump in and we get to start talking a little bit more about how energy flows through ecosystems. Now, all of these are our, not autotrophs, but our what? Heterotrophs. The energy that an herbivore gets is only with an herbivore forever. True or false? If you're an herbivore, let's say you're whatever herbivore you want to pick. You can be a cow or grasshopper or the whole variety of them. Whatever energy you consume and create throughout your life only stays with you. Is that true or false? False. Why? Ooh, I love that. Herbivores have some energy in them. Now, you guys also have energy in you. Are you letting go of your energy right now?
Yeah.
All of us are. Why? What's our body do with, like, we have to eat.
Moving.
So right now I'm not moving though.
Stay warm.
Staying warm. Most of our energy is lost through heat. Like, most of it. Now, we have various levels of energy that are needed, different numbers of calories depending on what you're doing and so forth and so on. But there's definitely a connection between the energy in an herbivore. Do you think the energy in an I'm going to switch roles here. Is a carnivore's energy very likely to wind up in an herbivore? Or is it option A, where these guys get energy, herbivores get energy from carnivores? Or is it more likely that carnivores are going to get their energy from herbivores? Why?
Because
They eat, yeah.
No cap. Okay. So as we go through stuff, very intentional. This class, you guys are always engaged, so I don't know that I have to use all the awkward words or not. But we're just going to start knocking these out. So today we are continuing on this lesson, and we're going to look at a few different examples and types of models that we will use as biologists to indicate how energy flows throughout an ecosystem. So, models of energy flow. Okay. We are all alphas, right? Like, for real though, like, what hunts humans? Kind of, not really though. Like, you think humans kill more wolves or wolves kill more humans? For sure. Are we really hunted? Do you have to, when you walk outside, do you think, oh man, I hope that I don't get eaten by... Yeah, like if you're hanging out in the middle of the forest and walking around with like stakes connected to you, I'd probably be concerned about it. But for 99% of people, you don't have to stress a whole lot about being eaten by an animal, yeah? We are at the very top of a what? Oh man, look at that. So we get 3 different types of organizations that we're going to look at. And auto and hetero, what were the words that we talked about? Trophs or trough, right? So as we're going through this, our first vocab before anything else, we're going to talk about trophic levels. And I'm going to do a quick search because trophic or trophic in your mind? I see trophic, but I am not the holder of all things knowledge. So I'm going to use old Google here to pronounce trophic. And I just want to hear it. Or trophic. Yep, good call. Looks like it's going to be trophic to me, but I don't know that.
Trophic.
Boom. Okay. Ick. Just for the record. Ick, not uck. All right. Trophic levels are what we're looking at. Now, by definition, I'll make sure that that comes out in all caps. Trophic levels. Am I going to give you a hard time to say trophic? No, not at all. Okay. Trophic levels. We're just going to say each step of the food chain that we're going to be looking at. So every food chain has a bottom and a top. These levels on a food chain are the trophic levels. Every level of, and then we'll see a few more different ways to think about these, but we'll think in food chains right now. All right. Yay or nay? Y'all have done a food chain before.
Yeah.
Okay. In health?
Yeah, food. Yeah, the pyramid food.
So careful. Food pyramid is different than a food chain.
Yeah.
Okay. Food chain probably sounds familiar. Food web?
Yeah.
And then not food pyramid, but energy pyramid. Not what you're thinking of, not with nutrition. So maybe you've seen them, maybe you haven't. Did you guys have life your 8th grade year or 9th grade year? Do you recall?
8th grade, because we did it before.
8th grade with Forfietta. Did you guys have Ms. Holloway or no?
Yeah.
We didn't get that.
No, because in 7th grade we got Earth and Science, and then
Ms. Holloway taught you Earth and Space Science, and then Ms. Forfietta taught you Life?
yeah.
Okay, cool. All right, so it's more recent for you than some like next year's kids will be. As we look at these, 3 different models that we worry about, you guys have seen this word. We're going to first define for ourselves a food chain. And y'all just indicated you've seen them, at least this one. What's a food chain?
It's like this
Variety of foods that other organisms would consume. So it's like, okay,
It's like the prey and then the predator.
Oh, okay. So for this, do me a quick solid. Check your vocab stuff that y'all did yesterday, which I gave back to everybody. How did you define food chain?
How energy passes through an ecosystem.
Okay, so I'm gonna write this, and I don't, for some reason, like that space right now, so I'm gonna have like an obnoxiously long arrow down here. I'm just gonna claim it is the simplest flow of energy. Simplest flow of energy through an ecosystem. Now, at the very beginning of this lesson, we said something is the foundation of every ecosystem. Did we talk about heterotrophs first or autotrophs?
Autotroph.
Okay, autotrophs, because what do they eat? They eat sunlight, right? And they don't really eat it, but I'm okay with that. The simplest flow through an ecosystem, first of all, autotrophs always serve as the bottom level. Now, food chains can be super gigantic and complex. Let's pick a region anywhere in the world, some biome or some specific habitat where we know 4 or 5 animals of that habitat. You want to do here? There's not many predators here, but we could do here if you'd like. You want to do here? Do we have another common geography that we all know animals of? I'm from South Dakota, so if I pick South Dakota animals, I bet you'd be okay with it. All right, so check it out. Let's do a quick example of this. I'm not going to draw animals, just so you know. We have in the prairies of South Dakota or in the forests of South Dakota, any idea what sort of plants grow? Okay, so and that's fine. We get a lot of wheat and hay in the prairie, and then berries and stuff in the forest. So let's say that we have wheat. Give me another animal you might find in the forests in South Dakota.
Animal?
Sure,
Is there a squirrel?
sure. We'll take squirrels. Any others?
a wolverine.
So no wolverines, not there. We do get a lot of deer and elk and that sort of thing. If I write this word, do you guys know what animal this is? A puma?
Yeah.
Oh yeah.
What is it?
It's related to the cheetah, I think. Or
So they're all related to each other because they're all big cats.
Big cats.
It's a mountain lion. That's what they're called where I'm from, mountain lions. And then let's see other animals that might exist. They're very few and far between, but you might have wolves.
Oh, yeah.
Now, this is not an extensive list, right? There's realistically a ton of more animals than I've listed here. Could you put these together in a food chain?
Yeah.
Well, let's try. If I try to make a food chain out of this, the direction doesn't really matter. So I should have done this initially, but I'm just going to rewrite these. What's at the bottom? What's a wheat? Okay, wheat. Now, when we're drawing these, and I need to check to see how your book does it, because as long as we're consistent with it, I don't really care about the order. But wheat gets eaten and feeds who? Okay, so we'll just pretend like this is just plants, but squirrels might eat wheat. Realistically, they'll probably eat nuts and stuff like that. But we have squirrels that eat wheat. So energy from wheat goes into squirrels. Anything else here?
Deer.
Deer also eat wheat. Okay. Now I'm going to just move down, and I'm working left to right for no particular reason. You can draw this in whatever situation you want. I'm going to put puma here. And we'll put puma, and we'll put wolves. Now, what I want you to notice is that regardless of how we organize these, and food chains can be messy, food webs can also be messy, like it's okay. we have three distinct trophic levels here, though. We have our autotrophic level, which is our root. And realistically, it's just all the plants, right? That's the very bottom level. There's a lot of plant. Now, all the energy in the plants, not all of it, but squirrels and deer get it from there, right? So they are consumers at this point in time. Now they're omnivores, that's fine. Not omnivores, herbivores, I'm sorry. But we have a different trophic level here. Squirrels may contribute energy, or their energy, unwillingly I imagine, to whom? Wolves? Wolves will eat squirrels.
Deer, no, wolves eat deer, right?
Wolves will eat deer too. Uh-oh. Our old-fashioned puma got left out.
Puma eats squirrels.
Puma will also eat squirrels. Will puma eat deer?
Yeah.
They will. Will wolves eat puma?
If they're in a pack.
They probably would, given the opportunity. I've never eaten it, but I've heard cat meat is not good. Just for the record. Like, people hunt puma where I'm from, and the meat, what I've heard is it's super stringy. It's not pleasant to eat cat. Now, looking at that, that's a food chain, and we can see how it works. That is super duper simplified, right? If we wanted to have a closer look at this situation, could we draw a much more complex and large, involved food chain?
Yes.
Okay. Now, in contrast with this, we have a lovely food chain listed here. This is starting to build up in complexity, though. Don't erase anything on yours. Is this picture really much different if I just do this? Oh my gosh. I'm going to go close that door. Is this tell a similar story?
Yeah.
Which one's simpler?
That one.
That one is simpler, right? There's less information on it. Now, there's some nebulousness, which, remember, nebula is a thing in space. It's like a big cloudy region that you can't really see through. So not necessarily black. It's just cloudy, like you can't see through it. So when we look at this, there's a little bit of, I don't want to say lack of distinction, but overlap may be a better word. Food chains are the simplest. This is bordering on moving past a food chain at this point. If we want a little bit more complex of a picture, which we can certainly create a more complex picture, we can instead construct a food web. So, next level, we have food chains, the simplest. We also have a food web. How did you guys define a food web in your vocabulary? Say that again?
Consists all of the food chains in a single ecosystem.
Awesome. So I am not going to write exactly that, but it's spot on. Love it. I'm going to say that if you have a single ecosystem, like if we stick in the forests of South Dakota, you could create like 10 different food chains, right? Now, if we had those two together, and I'm trying to go back here, if we take the same picture and we added another food chain to it, which we certainly can, there's other food chains that could exist. If we just, right now, and I should have done it, I might have gone too far this first time, we're going to define it first and we'll talk about it. So food web, any habitat, any ecosystem has a bunch of different food chains that exist. A food web is just a more complex picture telling the same story, but specifically we'll say it's a model with interconnected, or I'll just say connected. I wonder what's going on out there. Model with connected food chains of an ecosystem. Bam Bam, will you close that other door for me, please? Chains of an ecosystem. Thank you, sir. Appreciate it. All right. Now, food webs can get really messy and really complex, and they can get more and more complex just depending on how hardcore you want to draw them. I want us to look at one little picture. I'm not going to make you guys draw it. If you want to spend the artistic effort in drawing it, I don't mind, but I'm not going to require it. So we'll just awkwardly wait for this thing to turn on and work, and we'll zoom in. All right. So this to me, and I guess I'm more curious rather than just me. For this one, where do you think we're living to look at this? We have pronghorn, you have a roadrunner and a jackrabbit and a Gambel's quail and a weasel and it looks like a coyote, a whiptail lizard, a ridge-nosed rattlesnake, a tortoise, and a raven. I'd say you're probably in southern Arizona or northern Mexico. Like, this is a desert ecosystem. Now, why is this not just a food chain?
Because there's different predators and
Well, because it goes around.
Yeah,
it's all
it's
around.
it's more than one connected. Now, I made a slight mistake. I don't think it's a huge mistake. The first one that we drew, would you consider it a food chain or a food web? I drew a food web. That's my bad. I was just so excited about it because it's so fun to talk
Yes.
about. Now, as we look at this though, it's very clear that these things are connected to each other. Old tortoise eats cactus. Cool, look at him doing it. If we just want a simple food chain, tortoise eats cactus. Right now, do you see anything that eats tortoise?
No.
Oh no, does that mean it just doesn't work?
No.
No, because they don't show it, but who else do you think might eat some plants in autotrophs?
Pronghorn.
The pronghorn will, for sure. So we could also draw an arrow coming here and here, right?
Yeah.
And we could add more to this picture as well. Like, everything here is connected, and delicate balance exists within nature, which is why it's such a big deal if you kill one thing. Does a pronghorn eat jackrabbit?
No.
No, it'd be bizarre to see an antelope eating a rabbit. That'd be craziness. Roadrunner, will it eat plants?
Yeah.
Probably. Will Roadrunner also eat rabbits, given the opportunity?
Yeah.
Probably. Will this raven eat rabbits?
Yes.
Yes.
I bet it does. Ravens will eat rabbits, oh yeah. Will this wolf eat a tortoise?
No.
Probably not. It's not worth the energy that you put into it. I don't know what eats tortoises. My guess is that the raven or the weasel, once the tortoise is dead or caught out in the open or something like that. I'm not from northern Mexico. They're all connected, right?
Yeah.
That's a food web. Now, I'm not going to make you guys draw it. I think on your assignment you're going to be asked to make a simple food chain or food web. I'm going to say within reason. Don't go like crazy complex, which I appreciate your guys' willingness to like go above and beyond, but don't spend like an hour making a big crazy long food web. Okay. Do we need to talk more about food webs? Okay. Last little piece then. And today's lesson is really quick because we're about done with it. The last piece that we talk about, and these are all just same ideas, just expanding on what we're really focusing on. We have food chains, the simplest. Connect a bunch of food chains, and you now get a food web. And this last one you've probably never seen. We have what is known as an ecological pyramid. Okay. Now, I don't want to make you guys draw a bunch of crazy stuff, but I'm going to give you an option real quick. Do you want to work in like an ocean environment or in a like forest environment? Forest. Okay. How good's your pyramid drawing?
Some drawing.
Okay. Can we all draw a triangle if not a pyramid?
Yes.
Okay, so realistically, I'm totally cool with ecological triangles, but it doesn't quite tell the whole picture. So as we look at these, an ecological pyramid, by definition, it's going to be a model. Similarly, it is a model that instead of just showing what animal eats what animal, and so forth and so on, or which food chains connect to other food chains to make a bigger web, this thing models showing the energy. Showing, I promise I can spell. Energy in each trophic level. Now, this makes it a little bit easier to kind of pick out what trophic levels really represent, and we will get a few simple examples of what's going on here. Shows the energy in each trophic level. Now, for this, there's this weird little thing. It takes a lot of energy to raise a youngin to be big enough to be eaten and give energy to something else. Most of the energy in that animal's life is not passed on, right? They use it for their own life-sustaining purposes. So a follow-up comment to this is we're going to say at each level, only approximately, and this is not a like steadfast number, but approximately 10% of energy passes on. Is passed on. And we'll look at that specifically. All right. So I'm going to go crazy here, and I'm going to draw a quick pyramid to make an ecological pyramid. So here we go. E.g., if you were to draw a pyramid, how would you draw it? And I'm going to draw mine gigantic so I can write in it. You don't need to draw it gigantic. We'll just have the lines going out. If I want to draw a pyramid, how do I do it? I would start like this. And that's too wide. I don't like that pyramid. Let's do this one. Here it is. I'm going to draw this pyramid. It's beautiful. It's not a pyramid yet. Now, for mine, I do this. Now a pyramid. It's beautiful. Okay. For this pyramid, we have several different levels, and you could break it into more and more if you wanted. First and foremost, in anything, the base foundation of any ecosystem is the what? Autotrophs, which consist of what sorts of animals? Not animals, I'm sorry, that's terrible language. What sorts of organisms? Plants. So I'm not going to add in the third dimension unless you guys really want me to. It'd be this, if you wanted to show depth. Okay, am I cool with if you guys just use a pyramid or a triangle?
Yeah.
Bet. All right. Gosh, I don't know how I got so cool, guys. You're lucky. All right. So, the base of this pyramid is going to be the whos. Don't know why that happened. Where is it not closed? Weird. All right, don't care. Check it out down here, and I'll just do it green like this because it's going to bug me if it's not. Green for plants and algae, right? All these guys down here are our primary producers. So I'll just use this bar sticking out, and we have our primary producers. Now, if you think of a triangle, this area is going to be bigger than the next area on your triangle because the base is wider. That's what makes it a triangle. As we go through here, what we wind up seeing is our primary producers, they get all of their energy. Like, all of their energy gets used. They're autotrophs. They don't have to expend a ton of energy. They just get it for free. So we get 100% right now. Okay. Now, when we go a step up, if we're thinking like, and I asked you guys what biome or ecosystem you wanted to work in, and we can think about a forest. Who are our primary producers in a forest?
Like elks, deers.
Nope, too big. Autotrophs. Have to be autotrophs.
Oh, yeah. Plants.
Good. Yeah, they're plants, right? Like that's it. Now, who eats plants? Herbivores and things like that, right? So I'm not giving us energy amounts or anything here, but we have some herbivores that are going to be here. So our second level, our trophic level, all of a sudden we'll move up into our autotrophs, and these are primarily going to be herbivores and omnivores, right? So here's the deal. If our base level has 100% of the energy and only 10% is passed on, whatever we're going to call these, which we'll call these our primary consumers, primary consumer, how much energy is passed on between levels? 10. So I had 100% initially. Now I only get 10% of the previous level. So just looking here, herbivores. You don't have to write this if you don't want to, but I'm looking here. Okay, herbivores. They're our primary consumers. They're the things that eat the autotrophs. Keep getting bigger. Are there things that will eat herbivores or dead parts of herbivores?
Yes.
For sure. Primary consumers are at the first trophic level above our autotrophs. Who's on this next level then? What do you call, what's one after primary? They're going to be our carnivores and our omnivores, again, some more. We had primary producers, primary consumers. What do you think we're going to call the second thing? Secondary consumers. Now, here's where we're just going to do a little tiny bit of math. These are our secondary consumers. Every time we move up a level, we take how much percent of the energy? 10. So this is a weird idea. What's 10% of 10%? And that's a weird idea. I want to see what you guys come up with. I'm going to write a number here. Or 10% of the overall energy, if you'd rather. this is 1%, isn't it?
Yeah.
This is, and I hate the way that I'm writing this. Can I write it here and it's going to be inconsistent? It's going to drive me crazy.
Yes.
We're now at 1% of the energy that was at that base level, which makes sense because are there more plants or are there more deer?
More plants.
Yeah, are there more deer or are there more wolves? Wolves are a bad example there, but I'm okay with that. I should have picked one that had more stuff. Now, don't let the size fool you. Up here, we get like omnivores and stuff, right? So we have only herbivores, and then we might get some omnivores that live here. Then at this top level, who's king? Pure carnivores, right? Now, the last little part of this, we used this word yesterday, I believe. These are my third level consumers or tertiary. Third, tertiary consumers. And what percentage of energy would they get?
115.
So careful, why 15, Fred?
Well,
I shouldn't have said careful because that gave you an indication that you were wrong.
yeah.
Walk me through, how'd you get 15?
Well, I just figured out even 10%. I don't know.
So notice what's happened every time. What's 10% of 100?
10.
What's 10% of 10?
1.
What's 10% of 1?
Just 1.
So we're getting some decimals here. 0.1. Now, it makes sense that at the very top of your food chain or your food pyramid, or sorry, ecological pyramid, that all the energy that's left over, there's very little, right? Because we lose so much of it through heat and through just regular life. We have these different levels. All these ideas tell the same story, whether we're looking at food chain, food web, or ecological pyramids. I do want to show us in your book, they use an ecological pyramid and they have 3 different versions, but I'm not going to make us draw 3 of them, but we should discuss it. So the one that we just drew is going to be here, right there. Now, they talk about the foxes being the big dogs, which maybe they were actually here in the tundra, right? Except we don't get raccoons here. Now, beyond that, notice, we see population size gets smaller as you go up, which makes sense because there's less what? Less carnivores, but less energy, just total, right? Now, we haven't used this word. What's mass?
How big it is?
Weight, you can think of it as weight. That's not a perfect, but I'm good with it. Do you agree that the higher up you go, the less food is available for the next bigger thing? Okay? And same thing, available energy. Populations, biomass availability, and energy all decrease as you work upward on this pyramid. Now here, you see the same thing. Here's all this energy that we lose as heat. We have 100% of it, 10% of it, 1% of it, 0.1% of it. Could we have a 4th level consumer in a particular ecosystem, you think?
Yeah.
Probably. You could make this out. And then they're just talking about the density of these, which that's a weird idea to represent it here. But we just see there's a lot of plants. There's less fish. There's less big fish. There's less big fish. And we see the same thing happening all the way through. It's going to happen in every single energy or ecological pyramid that we deal with. Okay, so here's what I have for you. You guys get the privilege of, 1, knowing how to pronounce trophic, but 2, you get the privilege of having an assignment tonight. But remember, I am aware of your lives, at least to some degree. Today's the 12th, so we just finished 2.2.2 food energy models. Okay, ... I'm going to post the video here in a second. 1, 2, 3, 4, 5. Your homework this evening, and I'll zoom way in here. You get to work through homework 2.2, which you will find located on page 38. I want you to do problems 1 through 6. This will be due tomorrow at the start of class, just so you're aware, with the following understanding.